AMD just reversed a decision that triggered one of the biggest consumer revolts in processor history, and if you own a modern AMD CPU, you should care why. A few months ago, AMD announced they'd be ditching memory encryption from consumer processors. You know, that security feature that stops hackers from accessing your sensitive data even if they physically breach your system. The internet erupted. Users flooded forums, social media, Reddit. Security researchers issued warnings. And then something rare happened in tech. A massive company actually listened. AMD's now bringing memory encryption back to consumer CPUs, and it's a win that shows consumer outcry can change corporate decisions, even at the biggest chip makers. But here's the thing, most people don't understand what memory encryption does or why losing it would have been catastrophic. Think of memory encryption like this. Your CPU is a vault, and normally the data inside isn't scrambled. If a hacker physically steals your computer or breaks into a data center, they could read all the sensitive information in random access memory, your passwords, your financial data, confidential work files. Memory encryption scrambles that data, so even if someone gains physical access, it's useless gibberish. AMD's decision to strip it out was shocking. So why would they even consider removing a security feature everyone relied on? That's where this story gets interesting. Here's what happened. AMD realized memory encryption, also called Secure Encrypted Virtualization, or SEV, was eating into processor performance. In virtualized environments, where multiple users share the same physical hardware, SEV adds overhead because the CPU constantly encrypts and decrypts data. The performance hit isn't huge, maybe 5 to 15% in some workloads, but for cloud providers running millions of virtual machines, that adds up fast. AMD started planning to remove SEV from consumer CPUs. It seemed logical. Consumer machines aren't usually running virtualization at scale, so they wouldn't miss the performance boost. Cloud providers and enterprises would keep the feature on higher-end processors. AMD figured nobody would really care. Then the announcement dropped. The tech community absolutely lost it. Security researchers immediately pointed out this was a massive mistake. You don't strip security features from general-purpose CPUs. Even if consumers don't currently use them, they create a foundation for future improvements. Plus, virtualization is becoming more common in consumer scenarios, in containerized applications, virtual machines for development, cryptocurrency platforms all benefit from memory encryption. The backlash was immediate and severe. Thousands of comments, tweets, and forum posts from angry users. Major security experts gave interviews. AMD's reputation took a hit. It became clear that removing this feature would damage their credibility. So AMD made a decision that surprises everyone. They are reversing course. So here's how memory encryption actually works. Your CPU has different privilege levels. The kernel, the core of your operating system, runs at the highest level. Applications run at a lower level. This separation is a security boundary. Your RAM is where data lives during work. When you open a browser, it's running in RAM. Your email, your passwords, all sitting in RAM. If someone gets direct access to that memory, they can steal everything instantly. Memory encryption scrambles all that data, so it's completely useless without the encryption key. Here's the genius part. The CPU holds the key, not the operating system. So even if a hacker breaks into Windows or Linux itself, they get total admin access. They still can't read the encrypted RAM because the key never leaves the processor. This is called a threat model. AMD and Intel design security features by asking, what's the worst-case scenario we are protecting against? For memory encryption, the answer is someone physically stealing your computer or breaking into a data center. Without memory encryption, you're vulnerable to cold boot attacks. Hackers power down your machine, extract the RAM modules, move them to another computer. Data in RAM persists for a few seconds after power loss. It's literally just electrical charges, so they can dump and decrypt everything. This is why removing the feature was so dangerous. You're saying, we'll protect you from remote attacks, but not physical ones. And that bet doesn't hold up. Let's talk about real-world impact. Imagine you're a journalist covering a sensitive story. Your laptop contains encrypted files, encrypted emails, encrypted communications with sources. But your RAM, the active memory your CPU is using right now, isn't encrypted if the feature's been removed. A government agent breaks into your hotel room, physically steals your laptop, powers it down immediately. They put the RAM modules into a forensic extraction tool. Without memory encryption, all those active encryption keys sitting in RAM are now readable. Your security certificates, your session tokens, everything. The hacker doesn't need to crack your passwords or your file encryption. They just read the keys straight out of RAM. Here's another scenario. A data center in Eastern Europe gets physically compromised. Hackers sneak into the server room at night, extract RAM modules from active machines. Normally, without memory encryption. They've just hit the jackpot. Customer databases, payment information, medical records, all sitting there unencrypted in RAM. Memory encryption turns that into gibberish. A mobile device gets seized at a border. The customs agent powers it on and tries to extract memory before encryption keys lock down. Memory encryption on a phone means the active data is still scrambled. These aren't theoretical attacks. Cold boot attacks are real, documented, reproducible in labs, demonstrated on MacBooks and enterprise servers. They are one of the few attacks memory encryption completely stops. Without it, your only protection is hoping nobody gets physical access. So here's where AMD stands compared to the competition. Intel has similar encryption features called TME, Total Memory Encryption, which works broadly the same way as AMD's SEV. Intel faced similar pressures about performance trade-offs, but here's the critical difference. Intel didn't try to remove it. They recognized that even if a feature has a cost, dropping it entirely sends the wrong signal to security researchers and security-conscious customers. You don't retreat on security fundamentals. AMD's now aligned with Intel on this. Both companies are saying, memory encryption stays, it's part of the baseline, it's non-negotiable. The broader chip industry is watching. ARM, which powers smartphones and is moving into data center processors, includes encryption options. Qualcomm, MediaTek, Samsung, all of them are building memory encryption into their roadmaps. The message across the industry is clear now. Memory encryption isn't a luxury feature you can remove to save a few percentage points of performance. It's a baseline security standard. What's interesting is that this came directly from consumer pressure. There was no government mandate, no industry consortium decree. Users and security researchers just said, this matters, and AMD listened. That's rare enough to be noteworthy. It shows that in tech, sometimes the market actually does enforce good security practices. If AMD had gone through with the removal, competitors would have used it as a marketing advantage. AMD saved themselves from that PR disaster. So what does this mean going forward? First, it signals that security fundamentals aren't negotiable anymore. You can't just drop a widely used security feature because it costs you a few percentage points of performance. The market and the security community won't allow it. Second, it's a wake-up call to other chip makers. ARM is expanding into data center processors. They're watching this AMD situation closely. The message is clear. If you want to sell secure processors to enterprises and cloud providers, memory encryption needs to be baseline, no exceptions. Third, and this matters, it validates consumer pressure. We are in an era where companies are increasingly accountable to their customer bases on technical and ethical issues. You can't just make a decision in a conference room and expect the internet to shrug. But here's the flip side. AMD's reversal is good. But it shouldn't have been necessary in the first place. The company nearly shipped consumer CPUs without this foundational security feature. That raises a question: what other security shortcuts is the industry quietly considering? What other features are on the chopping block right now that we just don't know about? The answer is probably a lot. This is just the one where the security community had enough collective voice to push back. Memory encryption is also becoming more relevant as quantum computing advances. Future quantum computers might break certain encryption standards. Now let's talk practicality. If you own an AMD Ryzen CPU, how do you actually take advantage of memory encryption? Good news. For most people, it's enabled by default and you don't have to do anything. Memory encryption works at the hardware level. It's built into the CPU itself. As long as your processor supports it, and most modern Ryzen chips do, and your BIOS has it enabled, it's automatically protecting your RAM. If you want to verify that your system has it, here's how. On Windows, download CPUZ, a free utility that shows detailed information about your processor. Run it, go to the mainboard tab, and look for SEV support. If it shows yes next to secure encrypted virtualization, your CPU's got it. On Linux, open a terminal and type cat/proc/cpuinfo and search for the SEV flag. If it's there, you're protected. For server administrators and cloud providers, there's an additional step. Virtual machines can be explicitly encrypted using SEV. This is critical in multi-tenant environments where different customers' VMs run on the same hardware. The hypervisor encrypts each customer's entire virtual machine, so even if one VM is compromised, it can't access another customer's data. In AMD's Ryzen master software, which is like a control center for your CPU settings, you can sometimes tweak memory encryption settings. But for regular users on standard Windows or Linux, it's just there, working in the background, automatically protecting you. Here's what this story really comes down to. You got to watch a corporation actually respond to legitimate security feedback. AMD listened, and they're bringing back a foundational security feature. That's worth celebrating. But it's also a reminder to stay vigilant. Just because AMD backed down doesn't mean other companies will. The pressures on chip makers are real, performance matters, costs matter, feature optimization is a genuine concern. Somewhere right now, another company is asking whether they can cut security features to improve benchmarks. Your role is to care. Stay informed about these decisions. Follow security researchers. Read about hardware security, even if it seems technical. Because when the next company tries to quietly remove a critical security feature, the difference between them going through with it and backing down is whether informed users show up and push back. Memory encryption is now standard. It's normalized. AMD made it clear that removing security features from consumer hardware is a non-starter. That's the win. The system worked at least this one time. The broader lesson is this: corporate decisions aren't inevitable. You have leverage, even as an individual user. Your voice matters when amplified with others. This story proves it. As new chips from Intel, ARM, and others arrive, make sure they're including the security features you need. Don't let manufacturers incrementally strip security under the guise of performance improvements. And if they try, remember, the internet has memory, the community has voice, and apparently, companies do listen.